right. Welcome. We'll be starting in just a moment. I'm going to wait for just a few minutes for a few more students to join. Looks like we have a fair number. Um, please do use the chat feature. Um, we've got a few more minutes before, another minute or two before we're going to start. So um, say hi. Make me feel a little less lonely in here. One of the things I really like about teaching is just seeing everyone. So interacting with people. And so it's really quiet here. There's, yes, thank you. Harsh, Zachary, Dhruv, hello. Karan, Yeshi. Oh, excellent. Yes, there are people here. My voice is not just going out into the ether. All right. Um, Looks like a few more people are joining, but I am going to get going. All right, so welcome. This is database systems for CSE 400, 562. Um, Today we're going to talk about some fairly high-level stuff. We'll go into more in-depth course material later on. Most of what I want to spend today on is logistics, but I do want to kind of give you a sense of the flavor of the course itself. I'll be keeping an eye out on the chat, and Darshana, who just said hey, is our TA. Give her really give her a round of applause because there's 100 people in the class, and as of right now, she is the only TA. So she's going to be. Her reviews from last semester are amazing. So she's a fantastic TA, and it's not just me, faculty member, saying that. The students universally love her. So give her a quick round of applause. Um, all right. So on that note, I'm going to start. Let's get going. Um, so over the course of the lecture today and moving forward, we are going to be using a tool called Slido. You can feel free to scan that QR code with your phone. It's got a nice phone interface, or bring it up on your desktop. I posted the link already several times in the chat. Here it is again. Uh, Use that. I'll be bringing up polls or just kind of little bits of class interaction every so often. Participate. This is a way to kind of get even more interaction than just simple chat. Um, okay, so uh, let me start this off by just really enthusiastically telling you why databases are awesome, because they really are. And they are literally everywhere. You have a database in your pocket, or hopefully in your hand at this point. Every single smartphone has SQLite on it. And I mean, that's a database system. They are in nuclear control systems, they're in space, they're everywhere. And that sort of prevalence makes databases just freaking awesome. If you are here more for the bling, well, we got you covered. 8 of the top 10 software companies according to Forbes, are essentially have a huge focus on data management. And so, well, if you're looking for a job, there's few better options than database systems. On top of that, several of those companies, in fact, the top three, essentially their main product at this point is a data management tool or service. And my personal reason for enjoying databases is that it's a amazingly interesting problem. It takes real world problems and then applies every single aspect of databases, excuse me, every single aspect of computer science, and brings it to bear on practical real world challenges. Brings together algorithms, systems, hardware theory, just pulls it all together and um, it's just fantastic. So personally, those are my reasons for being here. Um, Let me activate the poll here. And well, why are you here? Take a few minutes, a minute or two. Oh, excellent. We have a lot of ninjas here. Fantastic. All right, I'll leave this poll open for just a moment, but let's move on. Um, Let me ask you one more question. So everyone here interacts with data in some way, shape, or form. Let me ask you, well, how does data affect you in your daily life? Let me activate that poll too. Storing and retrieving your data, okay. Everything, okay. That's data is value. Okay, that's a fun one. Help me remember stuff. Oh my God, yes. That is, without my phone, my brain does not work. Creating organizational and structure, yeah, okay. You're in the right place. Fantastic. Having to remember less. Oh yeah, I'm definitely in that pile. Helping make decisions. So if there's some really interesting questions around that. There's a seminar, CSE 715, that actually looks. We're actually going to be looking at decision making and how, in particular, how we can make decisions a little more fair. Check that out if you're interested. Relevant ads. Well, that is definitely a place where you can make a lot of money. Life. Okay. Some good answers here. We're going to move on. So, okay, that's how data impacts you. Now, how do databases help support those things? Well, we've already had some nice answers of well, to store and retrieve data, and that's actually going to be the fundamentals of what we're going to be learning in this class. Um, Databases or database systems in particular are all about storing and retrieving data. And I'm going to make that a little more precise. How do we ask questions about the data, and how do we safely store and manipulate stored data? Now, databases is a little bit different from other subjects. In particular, we don't have kind of one specific tool that we are known for, the database community, that is. Instead, databases is more of unified by the specific types of problems that we solve. And to that end, what we have is a pretty diverse tool belt of techniques, recipes, and knowledge. Things like how do you organize your data? How do you choose the best algorithms for your data? What kind of algorithms even exist in the first place for doing common data transformations like joins? What kind of data structures exist? And then just kind of like underlying knowledge about the systems concepts like the memory hierarchy and data consistency. Now, I'm kind of hoping that you've already learned a lot about these in your other classes. I will be covering most of these subjects just to kind of bring you up to speed or give you a refresher. But essentially, what we're going to be doing in this class is taking all of these concepts and then tying them back together to address the specific challenges of quickly and efficiently asking questions about data and quickly and efficiently storing and persisting data. So, under the hood, what we're going to be learning about essentially is, well, we have all of these tools available to us. So now the real question is, well, which of those tools are right for the current situation? I have a specific problem I need to solve, a specific set of constraints on my design. Which of these tools that you've picked up throughout your entire CS career are appropriate, and when should you use them? So to that end, uh, the majority of this class is going to essentially boil down to I have some specific task I want to accomplish. I have some constraints on that task. And I essentially want to figure out, well, how do I solve that task efficiently? And in order to do that, first I have to um, define for myself what it means for a solution to that task to be correct. Then I want to have some sort of uh, specification of what it means for one solution to be better than another. And once I've defined this, that essentially gives me my problem. From there, I want to figure out kind of what tools, techniques are appropriate for that particular situation. And then finally, given all of this together, um, the best option, the best solution for that particular problem kind of just falls out. And while the specific X and Y are going to be different throughout the course, over the course of this class, pretty much everything we're going to learn in this class is essentially going to follow this template. What is a correct solution? What does the best solution look like? Or what are the characteristics of the best solution? What are solutions that we could use? And then given all of that, how do we find the best solution to the entire problem? Okay, so hopefully I've excited you about the class. Now let's get to the slightly less interesting but still necessary course logistics. What do I expect of you? First off, I expect that you have at least some background in algorithms and data structures. At a minimum, you should be able to look at an algorithm and tell me what its worst case complexity is. I also expect at least some familiarity with sort algorithms, tree structures, hash tables, the basic data structures that kind of form the bulk of CS. I expect you to know how to use a database. Towards the end of this class, I'll do a really quick recap of SQL, but essentially I expect you to have already at least used SQLite. And if you haven't done that, I've a good book on the course website that is a fantastic primer to kind of get you started. I also expect Scala. So over the course of this class, we'll be working on a project essentially built off of real world code. We're going to be hacking on Apache Spark, and Spark is written in Scala, which means that you will also need to know or at least learn Scala. Now, don't let that scare you off completely. If you are familiar with Java, C++, C Sharp, that is usually enough to help people, to allow people to kind of pick up Scala pretty quickly. We will be doing a, quick tutorial on Thursday to cover this material. That said, I do expect you to have at least some programming experience. Um, This basically means if your experience is I've built models in Keras, TensorFlow, what have you, this may not be the class for you. If you've actually programmed real programs, you should be able to pick up Scala pretty quickly. And like I said, we'll be having a really quick tutorial on Scala on Thursday, and Darshan and I will both have office hours that will be happy to guide you through the quirks of Scala and the compiler. So on that note, the course staff at the moment consists of two people, myself and Darshana Balakrishnan. Um, she's in the chat. As I've mentioned earlier, she got amazing reviews last semester. Students love her, so y'all are really lucky. So if and I want to emphasize this point, if you have any problems, any challenges, if you think the workload is too hard, if you think if you're running into a wall with any part of the class, if you feel just if you feel you're not keeping up with the class, or just if you want to talk about literally anything, please stop by office hours or schedule an appointment with one of us. Uh, Darshana has a busy schedule. I have a busy schedule, but we are more than willing to make time to help students who need it. So on that note, the course website is linked there. It has literally all of the information that you need for the course. I'm uh, a, this will include links to the videos after the fact. I'll be emailing those out and posting them on Piazza moving forward rather than posting them ahead of time on the website. Piazza will be our course management system. We're using a licensed copy of it, so there's been some worries that it'll have nagware this semester. If that shows up, give me a shout and I will yell at people. And as you've already noticed, we'll be using Slido for kind of in-class polls. Just get a sense of what folks are thinking during class. Uh, right. Okay, in terms of course textbook, I will not be requiring any official course textbook this semester. However, there is a fantastic book that is an amazing reference for this class called Database Systems, the Complete Book by Garcia Molina, Ullman, and Whittam. And it comes in two versions. So there's one version, the official version, and then there's another version that you can sometimes find on major online resellers that is officially licensed for use in the Indian subcontinent. Um, there are two major differences between these versions of the book. Version number one, difference number one is price, and difference number two is, well, the official version has an index and a table of contents. The unofficial version, or the version for the Indian subcontinent, only has a very rough table of contents in it. Over the course of this class, you will learn, among other things, why an index and table of contents are worth $100. Okay, in terms of course structure, your grade will be determined by two components. 50% of your grade will come from concepts. This includes uh, this includes 20% homework grades. This will be your homeworks will be done in groups of up to four. There will be approximately 12 assignments, roughly one a week, and you'll be allowed to drop any four of them for whatever reason you like. There will also be a comprehensive final on a date to be announced as soon as I have it. Usually, UB Learns shifts these times and dates around for the first week or two of classes. So in about 2 weeks, I will announce the actual date of the final. And then I know some people do better on homeworks. I know some people do better on exams. So whichever of those two you do better on will count for 30%. The remainder of the class, or the largest part of the work for this class is the practical component. So you'll be essentially rebuilding the guts of Spark SQL, a component they call Catalyst. This will be a solo project. Past semesters I've had this as a group project, but we are changing it around a little bit. It should be a little bit easier to do, but now the projects will be individually assigned. There are going to be 4 checkpoints plus kind of a checkpoint 0 that's essentially going to be free credit, and I'll explain these in a few moments. Lectures, as you already know, are on YouTube. They will be streaming Tuesday and Thursday from 12:30 to 2, and they will remain on YouTube, available for later replay. You don't actually need to attend. I'm not going to do any sort of attendance taking or anything, but you are paying me to be here. You are spending money so that you can interact with a human being. Um, if you want to give that up, okay, but I really, really encourage you to be here. It is a huge loss to you if you're not. I will be monitoring the chat, so if you have questions, um, do a quick, say something in chat. Um, and while I can't see all of you individually, something that I'm really disappointed by, one kind of perk of being online is that you can just ask. If you ever have a question, don't worry about interrupting me. Just type something out. Maybe somebody is going to respond. Even if someone doesn't respond, I will do my best to answer it as quickly as I can. And on that note, everything is online. It's very easy to kind of forget that we're all human beings, forget that we're looking at text rather than actual humans. But there is a human being at the other end of the chat. There's a human being at the other end of Piazza. So please keep things civil. Please be respectful of your fellow classmates and the course staff. Um, okay, so with that, let's get to the course project. So we're going to be working on a system called Apache Spark. Many of you have probably heard of this. It's one of the dominant tools for data transformation, data processing. Major components for machine learning, as well as analytics. Now, I have created a version of Spark that I'll be releasing in a few days that is essentially the main chunk of Spark's SQL processing system called Catalyst. And I've essentially taken out all of the GUI center. And what is left is essentially a parser and the relational algebra trees. If you don't know what that is, well, we'll cover that. And the frameworks for representing and evaluating single primitive valued expressions. Um, so that is still there. Um, your goal over the course of the term is going to be to replace all of the little components, all of the components that I've torn out. Well, okay. Rebuilding Spark from scratch is way out of scope for this class, but there are going to be three major components that I'm going to ask you to replace. So the first is a component of Spark called analysis, which is essentially boils down to tidying up some corner cases in SQL. So SQL is a language designed for use by users and not by compilers. And so typically in Spark, when people use Spark, or when Spark tries to answer a query, it will kind of first take the basic thing that it parsed out of the SQL and then kind of clean it up a little bit. I'll explain in a couple of lectures what I mean by that. Um, Also, there is no more code that actually implements the query. So you'll be responsible for that. But well, don't worry, this is kind of the biggest part of Spark. Unlike you're not building a full distributed system. What I'm going to be asking for is essentially just Spark, but implemented on a single node. And then with all of that, I'm also going to be asking you to implement uh, essentially the Spark's optimizer, the parts of the system that essentially take the query, the query plan, get rid of any redundancy, and figure out which algorithm is the best for the particular query that you are being asked to answer. So what we're going to give you, what we're going to give your code specifically, is this gutted version of Catalyst. We're going to give you data in the form of CSV files. We're going to give you schema information, and essentially what what your code is going to have to produce is answers to those queries. And over the course of the semester, those answers, the time requirements on those answers are going to get progressively tighter. Now, this is meant to be a real-world challenge. The You will be graded on correctness. If your code produces the wrong answers, well, that will not be that is not correct code. But getting the correct answers will only get you about a third of the credit for the class. For the most part, what databases do is they take these queries and they essentially try and figure out what the right algorithms are for that particular query, which means they pick algorithms that are likely to produce answers fast. So essentially, what I'm grading you on is not whether your code picks the right algorithm, but whether the algorithm whether you're able to answer the queries correctly and efficiently. And I will tell you exactly what you need to be able to do that. I will tell you exactly the steps that you need to take to get an A. But don't feel constrained to that. If you want to do more or you want to do something differently, you see something that I'm telling you that isn't that doesn't make sense to you, try something different. This class is also meant to be a little bit of a lab to give you a place to experiment with different ideas. So there's a question from Amneet. Is knowledge of Spark or distributed systems required to do well in this course? No, not at all. Scala, Scala is, you will obviously need to know or learn Scala, and as I said, we'll help you out with that. Distributed but Spark itself will be covering every single aspect of Spark. And in particular, one of the reasons I chose Spark for this class is that it was developed by database systems people. And all of the concepts in Spark map amazingly well down to all of the concepts that we cover in this class. So there, I hope to really show you that one-to-one correspondence, and I really hope to show you how the concepts that you're going to learn in class are going to make it into real-world systems like Spark. So no, you don't need to know any Spark already. And as I said, the system that we are going to be building is Spark, but single node, so you don't actually need to know any distributed systems for this particular course. We will be covering distributed systems concepts later on in the semester, but for the programming component, there will not be any. Hopefully I've answered your question. If I haven't, just shoot me another question in the chat. Okay. Um, Now, while I will tell you exactly how to get an A, there is kind of another perk in this class. Over the course of the semester, I'll be maintaining a leaderboard of performance. Now, just to make this clear, the leaderboard will only show up if you exceed the performance required for an A by a significant amount. And as soon as we've had some really nice things come out of these leaderboards. Like some group discovers this one little hack that suddenly makes their system like 10 times faster than everyone else, and then they become suddenly very popular because everyone wants to know why, how they did it. So uh, I we will be posting those leaderboards, and I encourage anyone who like is really enthusiastic about this sort of thing to try those out. Um, but you will those are bragging rights only. Historically, I've also baked cheesecake muffins for top performing students. Unfortunately, with COVID, that is no longer possible. So bragging rights only this time around. Um, w- uh, did Digant, please tell me how to pronounce your name so I don't butcher it in the future. But Digant asks, what are the minimum system requirements for this course, and do we get cloud access? You can do this on any computer system that can run Java. I have been developing Spark pretty extensively on a 7-year-old computer until fairly recently. It You don't need anything serious. There will not You will not need cloud access for this class. We'll be using an automated grading system, um, but you will not need any sort of cloud access. So again, to emphasize the point, we'll be using Spark's interface. All of the code that you will write will work with actual Spark, but what you are going to be building is going to be a single is going to be intended for use on a single computer. It will not be a distributed system. Okay, so moving on to the project itself. The project will, or kind of continuing with the project, like I said, what you're going to get, what your code is going to get is a SQL file that essentially consists of two parts. It'll consist of create table statements that are going to give you the schema, and it will consist of select statements that are the actual queries that I'm asking you to answer. Now, one thing that is a little bit confusing here, and I want to emphasize this point, just I'll probably end up emphasizing it again, is that the create table statements don't actually create, are not actually intended to create uh, tables. They all they are there is to give you a schema. We will also give you CSV files, and the create table statement is essentially just going to be a statement that says um, there is a CSV file with actual data, the create and has the schema that is defined by the create table statement. And I'll clarify that a bit more moving forward. Eshwar asks, do we need experience with writing SQL queries to do well in this course? So you don't actually have to have experience writing SQL queries, but if you don't know SQL, if you don't know its capabilities, it might be a little bit harder. Um, Essentially, after today, you will probably not, we will probably not deal with SQL all that much at all. And this includes both the project as well as this includes the project as well as in class. So most of what I use for query processing in this class is relational algebra. And Spark actually uses the same internal representation as well. So we'll be covering relational algebra over the first couple of weeks, and if you follow that, then you should be fine, even if you haven't really done much work with SQL. Um, Obviously, having that experience will be a plus, but I don't think it is completely required. And once again, I hope I've answered your question. Uh, Follow-ups in the chat. Okay, so again, the create table statement doesn't actually create any data or create is not meant to create data or kind of create a space where you can store data. The create table statement just creates, just registers the schema of the table itself. And then I'm going to pose query, the system's going to pose queries to your code. And there will be CSV files stored in a known location that the queries are supposed to be run on. You're going to take the CSV file, the query, and then produce an answer, print that answer out to the console. We'll check to see if the answer is correct and if you produced it in a reasonable amount of time. And that is essentially going to be the basic framework for what your project is going to do. Now, SQL is, as I've said, full of corner cases and kind of hard to work with directly. So what most database systems do is they translate it to an internal representation that has fewer corner cases that's easier to work with. And the one Spark uses, and the one we'll be talking about in this class, is called relational algebra. Um, so the select statement, together with the schema of the tables that it uses, go together to form this relational algebra plan. And this is the responsibility of the parser that you're going to get, as well as this analysis phase that you're going to implement. Now, that's basically the first, excuse me, that's basically the first project, produce answers. And then over the course of the semester, essentially what we're going to do is start making the timing constraints progressively narrower and giving you larger data to work with. And in order to produce answers to queries in a reasonable time frame, you're going to have to kind of manipulate this plan, work with it, come up with better algorithms, come up with kind of figure out what the best way to answer this query is. And as you can see, this particular query has racing stripes, and therefore it is fast. In order to do that, you need an optimizer. So initially, we'll be working with for project checkpoint 2 or so. We'll be working with an optimizer that just that is sort of stateless. It doesn't really need to know anything about the data. There are often some transformations that just work regardless of query. Some things that you can do that just make queries faster. Period. And we'll talk about those in class. And then for checkpoint 4, we'll be introducing a kind of warm-up period where your code is going to have a little bit of chance to analyze the data, look at it, and gather some statistics, pre-compute some things. And once you have those, it'll be the optimizer will go even faster because now it has information that it has more information that it can use to select to select from among the different algorithms that it has access to. Okay, I'm going to make this a little more precise. Checkpoint 0, I'll be posting this as soon as the auto grader as soon as we have auto grader access. And this basically just amounts to a hello world program. Here, this is essentially 5 free points. All I'm really testing is whether you can produce a Scala program that prints a statement. And just making sure we're going to debug the submission workflow before you actually have meaningful projects to submit. Checkpoint 1 is essentially going to be more focused on correctness than on actual performance. So here, I'm going to give you queries. You're going to have Spark's Spark's parser, which is going to give you a component that Spark calls a logical plan. Um, this is what I would call relational algebra tree. And you're essentially going to have to try and take that tree and transform it into something that you can actually get answers out of. We'll talk about this in more detail in the coming classes. But essentially, you're going to read the data out of the CSV files and then run some basic queries over the CSV files. There will be a few other things that you need to pull off. In checkpoint 2, now we're going to actually start looking at bigger data sets. The functionality that you'll be expected to support is going to go up a little bit. So this includes order by and limit. And as I said, you're going to be working with larger data sets. So where in checkpoint 1, you could get away with purely in-memory algorithms. In checkpoint 2, there will be at least 1 or 2 queries where you have to work with disk as well. Checkpoint 3, we're going to move to aggregation. This is uh, something that doesn't really fit anywhere else, but doesn't really make sense to integrate anywhere else. So this is going to be a fairly short checkpoint. And again, really what I'm looking for is correctness. And then finally in checkpoint 4, we're going to have, you're going to have a little bit of extra time at the start to compute things and to pre-compute statistics, pre-compute pretty much whatever you want. There's a good deal of flexibility. There's a couple of different ways to get an A on checkpoint 4. But essentially you're going to be you're going to have a little bit of time to pre-compute, and then once you've had some time to pre-compute, you'll essentially be asked to answer queries even faster, even faster than before. Okay, so this is historically has been a really fun project, and folks have gotten very excited about it. What I want to know is like uh, what parts of this project are you especially enthusiastic about? Um, this is both meant to help me tailor future editions of the class, but also kind of to adjust my expectations, or kind of maybe shift some of the requirements around, if there's a huge amount of interest in one particular aspect of the project. Oh, excuse me. I brought up the wrong. Wait a minute. Oh, little technical glitch here. I don't seem to have. Well, all right. Apologies. I'll skip to the next slide. Um, let's respond in the chat. What parts of this project do you want to see an emphasis on, or that kind of get you excited? That things that you'd like me to know moving forward. Okay, and while folks are answering that, let's go over kind of the flip side. So I've hopefully told you what it takes to succeed in this class. Now let me give you some advice for how to fail at this class, so that you can not do these things. So first off, this is going to be not an easy project. It will involve a fair amount of time. And if you wait until the very last minute to start it, if you only start it on the weekend before it's due, you will not have enough time to pull it off. So basically waiting until the last minute, that's a fantastic way to fail the class. Um, Office hours as well. Office hours are, I mean, I can't tell you how many people just kind of got scraped through in this class just because they were literally in office hours every single faculty and TA office hour. I can name a handful of students that were just there every single time, and they started off not doing great in the class, and then by the end of the term they were doing marvelously. um, Office hours are a fantastic resource. Plus, on top of it, it means I get to see your face. I mean, I enjoy working with people, so like use this opportunity. You're paying for it. Um, and even if you don't use office hours, we have a handful of resources, both Piazza, in class, the chat in class, Um, Ask questions. Um, there's no such thing as a dumb question. Like if you have a question, I guarantee you there's at least one other person in the class who has exactly the same question. So speak up. I promise I will not laugh at your question unless it is legitimately funny. Um, and finally, also kind of tying back to the project being being kind of difficult. Um, you will be allowed to submit your project as many times as you like. And every single time you're going to get a detailed report of what went wrong, where it went wrong. And if you wait until the very last minute in order to submit your project for the first time, I guarantee you there will be something in the grading script or something in the format of the answers that was unexpected, and you're going to get a failing grade on that test. But it's something that literally 2 lines of code would have fixed. And if you wait until the very last minute, you won't learn about that until the very last minute either. So submit early and submit often. All right. Cool. So those are kind of the ways to fail the class, and there's a fifth way that I really don't enjoy talking about, but I do kind of need to. Cheating. I really, 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 really hate it when people feel like they can get away with not doing the same amount of work that the rest of the class is. Um, Nothing, and I mean nothing, drives me as insane as people who submit code that they did not write or a homework assignment that they did not complete themselves. Nothing. So, I know there are different cultural expectations. I know different people have different definitions of what cheating is. So I'm going to be very precise here. Cheating is submitting anything, any code, any uh, text, any homework that you did not complete yourself and pretending, either explicitly or by omission, in other words, by not citing your sources, um, pretending that that submission was yours or creating the perception that that work was yours. Citations are fantastic. If you cite your work, that is great. If you cite your sources, that is great. We will grade you on what you yourself did, but it is not cheating specifically if you cite your sources. Okay, now just to make that a little more precise, what do I mean? What is okay? What is not okay? References in general are okay. Things like Wikipedia, Wikibooks, in general, as long as you are citing your sources and as long as the question that you're being asked to answer isn't literally spelled out in the source, this is okay. Code, on the other hand, is not. Um, In particular, you are going to be hacking on an actual system. Now, my personal view is Spark is complex enough that if you look at their code, um, you're going to spend a lot more time trying to understand their code than you would that it would than it would take you to actually just write the code yourself. Um, but that is not okay. Um, Taking code from outside sources, Stack Exchange, GitHub, that is not in bounds for the course. The Your goal here is essentially to rebuild, reconstruct from scratch practical real-world systems. The common term for this is you're building a clean room implementation. And when you're doing that, essentially, if you look at outside sources, you're essentially in the real world, you're essentially exposing yourself to lawsuits, your company to lawsuits. So um, the code is out there, but if you look at it, if you use it as a resource, that will get you into trouble. Now, in terms of idea discussions with classmates, I would be thrilled if you talked to each other about concepts and ideas. Um, Talking about things like, hash index has constant time lookups. This is fantastic. I work with each other. This another advantage of taking classes here is that you have not just me and Darshana to work with, but everyone else. Explaining things to other people solidifies the ideas in your own mind, and studies have shown that students learn a lot better from each other than from the faculty. So. Um, Discussing among yourselves, I think this is fantastic, as long as your discussions are at the idea of concepts or are ideas. Um, Obviously, not during exams, but hopefully everyone recognizes that. Specific answers, on the other hand, are not okay. So it is not okay for you to give someone else a specific answer or to share a specific implementation, or kind of just showing people what you've done, um, so, hoping that they kind of absorb the ideas. That is not okay. As Darshana points out, if these are kind of the extreme cases, we're more than happy to answer specific questions about what is okay, what is not okay. Um, so, please ask us before doing something that could get you into trouble. Um, I have a bunch of tools for detecting academic integrity violations in my toolbox. One common one that I use is called MOSS. Many of you are probably familiar with it. And essentially, just to give you a sense of what we're doing here, it looks at how much code overlap there is, how much overlap there is in the structure of the code that is being developed. And it's really good at kind of figuring out when two people have submitted code, even if the structure of that code has changed significantly. Um, Now, we don't, Moss is never a definitive. We never look at it and see, oh, you've exceeded this threshold, and all of a sudden you're guilty or not guilty. Um, but I do use it, and it kind of helps me keep track of which submissions I need to take a closer look at. Um, Now, I have a zero tolerance policy. If you submit someone else's code, if you submit homework that was taken from a source outside of your group, obviously, if you submit the same answers or answers that I can provably link to someone else's answers, on an exam, you will fail the class. This is departmental policy, and while there is leeway for instructors to impose softer penalties, I do not do that. And the reason for that is that there's 100 people, give or take, signed up for this class, and 99 of them are going to be putting in all of the work. They're going to be doing every single thing that they need to do um, in order to legitimately earn the grade that they get. And if you unilaterally decide that you're not obligated to put in the same amount of effort, then I'm sorry, that is incredibly disrespectful to the rest of the class, and I will fail you. That includes responsibility in the group. My group mate did it is not an excuse. I will fail or at least penalize the entire group. And since there are few ways to actually figure out who originated a piece of code, in general, If someone else submits your code, you will be penalized as well. Okay. On that note, does anyone have questions or concerns? I'm happy to take those. Wait a moment for the stream to catch up. Okay. If you don't want to ask questions in public, that is also fine. I am more than happy to answer specific questions about my academic integrity policy through email or on Piazza. All right. Um, so what, um, so under the hood, oh, actually, we're running a little late on time. Okay, I'm going to really quickly jump to, okay. All right, so kind of zipping through this. Um, what is a data management system responsible for? So I've already kind of given you a little bit of an answer to this. Well, it's answering questions about the data and um, so malpractice by a group member, Hitesh asks, uh, notes that malpractice from a group member, excuse you. I expect you to keep an eye on your team. The homework assignments are fairly light. You can work on them uh, in person. Just to be clear, I I respect that there are going to be there is a gray area in a lot of places with respect to academic integrity, but at the same time, if let me be clear about this. I may not catch you, and that is something I accept. But if I can come up with verifiable evidence that you are responsible or that you implicitly allowed a teammate to be responsible for submitting code that, or excuse me, submitting code or a homework assignment, then I will be incredibly harsh. Um, yes, we will be. So Adesh asks whether we can use Git. Yes. Over the infrastructure for this is still coming up. Normally, I like to have it done by now, but we're changing the project this semester, so it's taking a little longer. But yes, we will be using Git as a way to submit projects, and um, one of the things I do look at is the Git history when deciding whether or not something is an academic integrity violation. Will I be assigning groups or do we have to look for teammates by yourself? So the homework assignments are also not really meant to be, they're not really meant to be incredibly challenging. They can be done individually, and there will really not be much penalty in doing that. The main reason that I'm doing group homework assignments is that it's really difficult to study individually. I know a lot of students really enjoy kind of just collaborating with other students on when trying to understand the material for the course. So if you are in a position where you work with other students, um, by all means, up to 4 students can submit one homework assignment together. Um, if you're not, then there's really no penalty for it. And honestly, the main reason for the homeworks is so that you pick up the concepts and do well on the final exam. So if you don't put in the same amount of effort as somebody doing the homework by themselves, then you're really only hurting yourself. Um, so I will not be assigning groups. I'm simply giving people the option of submitting homeworks together. Hopefully that answers your question, Elijah. Okay. What does a data management system do? So I've already kind of given you a little bit of an answer here. It answers questions about data, and it stores and persists data. There's another system in computer science that has a very similar profile. Um, Excuse me, yeah, right. There's another system in computer science that has a very similar profile, a file system. So databases in a lot of respects are very similar to file systems. But there's one major difference. In a file system, the data is opaque. In a database, there's actual structure to the data, and the database is going to take advantage of that structure in order to make things faster and more efficient, both in terms of answering questions and in terms of updating. Um, there's a question from Nathaniel. Will all the homework assignments be available at the same time, or will you open them weekly? I will post homework assignments on a week-to-week basis, just because the amount of time that it takes different semester for a particular part of the class varies by semester. Some people have more questions about some topics than others, and those tend to go a little bit more slowly. So I will be assigning homeworks as we go along. Okay, getting back to it. So databases take advantage of the structure of a data set, of a data of the user's data. So let's define a couple of terms that we need in order to understand that structure. So this slide you can kind of go back to. This is kind of my general definitions. If you're not familiar with these terms, then you should be. Um, I'm going to refer to basic data building blocks like integers, floating points, characters, strings. Yes, I'm including strings in here as primitives. Tuples are collections of primitives. Um, Sets are collections of unique elements, and all of those elements have the same type. They are all the same type of primitive. They are all the same tuple type, what have you. A bag is like a set, but lifts the uniqueness constraint. It is an unordered collection of records, and all of those records have the same type. And then a list or a sequence is an ordered collection of records. So it's like a bag, but here we're going to assign an individual order to those elements. How does this fit into a database? Well, a relational database consists of a set of relations, or more commonly, these are referred to as tables. And each relation has a schema, which defines the type of the elements in that relation, as well as names for each individual element. And it contains an instance. The instance is just a fancy way of referring to the actual data in the relation or table. The data is, and accordingly, the schema is subdivided into a set of columns. And if I refer to the degree or the arity of an instance, relation, or schema, that is the number of columns that show up. And then obviously the instance is a collection of records. So every record or tuple or row is one element of the instance, and I'll refer to the cardinality or the size of a relation as the number of rows in the relation. Okay, time to wake up a little bit. I'm going to give you right now a unordered set of tuples, and every tuple in that set has 100 attributes. Now, one of those attributes is special, the first one. The first one kind of identifies the tuple, and the remaining 99 attributes are just interesting features of that tuple. Now, tomorrow, I am going to ask you for some of those tuples. And in particular, I can even tell you that I'm going to ask for 5 specific tuples. And those 5 specific tuples are identified by that one identity attribute. And I'm going to do this not just once, but over and over and over again, thousands or even hundreds of thousands of times. I will ask you for 5 tuples identified by that first attribute, and I'm going to not even ask for the entire tuple. I'm just going to ask for one of the 99 remaining attributes. And I'm going to do this over and over and over again. Okay, so now there's a feature in Slido that should just pop up right now. Um, how do you do better? There's is there a better way to organize the data that is going to answer that query more efficiently? You can answer either in Slido or in chat. Indexing, the first attribute. Okay. Group by the identifier attribute. Yep. So one strategy that we can use to organize this data a little bit better is to take all of these records, this huge collection of records, and kind of put them together so that we can really quickly jump to the specific 5 records that we want. Indexing. Oh man, everyone is saying indexing. And there's a couple of ways to do that. You can either partition the data into different chunks, or you can sort the data. And that's another way of very quickly jumping, being able to very quickly jump to the specific records that you're interested in. Hash index, right? So you can sort, or you can organize them by hash. Okay, good. So there's another so this very quickly addresses the point that I need 5 specific tuples identified by one attribute. Can anyone think of a way to take advantage of the fact that I'm telling you that I'm only going to need one specific attribute out of the tuple? All right, just in the interest of time, um, inverted indexing. Okay, so that is kind of what I'm going for here. And actually, you're right. So let me make that a little more, or move that without, state that without using the technical jargon. Um, so instead of having one record, one way to make this process quite a bit faster. So if I have 99 fields, but I only need one, there's a rhyme in there somewhere. Um, the I don't actually need to read all 99 fields when I'm answering the user's query. I only care about the one. So instead of storing all of the tuples joined together, one thing I can do is split them apart. I can have I could do the same sort of grouping or partitioning sorting strategy, but then I only store pair two. I only store the identity tuple along with the sorry, the identity attribute along with 90. Actually, I store 99 copies of the identity attribute, each paired with one of the 99 remaining attributes. Okay, now why am I asking you this? Well, one reason is that this is kind of exactly what databases do. They look at data and they look at query workloads and they essentially jump back and say, hey, if your data were organized in this particular way, it would be a lot more efficient. But another kind of really cool feature of databases and SQL in particular is that it is declarative. And what do I mean by that? So declarative language, as opposed to an imperative one, is a language that allows you to specify what you are interested in rather than how to compute the result. And among other things, this means if you can specify only what you are interested in, it means that you don't need to think about the algorithms as you're posing the question. Um, if you it's one fewer thing to worry about and lets you focus on the specific questions that you're trying to answer. But more importantly, it decouples it decouples the query from the underlying data representation. So in a database, and this is again one of the really nifty things about databases, you don't necessarily need to have one fixed data representation. The data was stored in its original format, or the data was stored in this new representation. In both cases, you could pose the same query, and the database essentially figures out, well, first, how do you answer the query with the data representation that you have, and then more importantly, what is the most efficient algorithm for the query given the representation that the data is in? So in an imperative language, even if the interface was designed in such a way that you could kind of take advantage, you could um, change the data representation without changing the algorithm itself may not be as efficient on the new data representation as the original one. And that is kind of the awesome feature of SQL. And in the last 20 minutes or so, I kind of really quickly want to run over just kind of uh, really quickly do an overview of SQL. If you've seen it, if you're comfortable working with SQL, then thanks for coming. You're not going to learn anything in the next 20 minutes. I'll see you on Thursday. For those who do want to stick around, just really quickly, SQL is a declarative language developed by IBM for a database called System R. 50 years ago, it kind of quickly developed into a standard and has undergone a number of revisions. SQL 92 in particular is roughly where I believe Spark is. And it's 92 is essentially what pretty much every SQL system supports. There's kind of additional extensions on top of that that may or may not be implemented, but that's kind of the basis, and that's what we're going to be talking about today. So basic SQL query is composed of three parts: select clause, a from clause, and a where clause. And just because select has multiple meanings depending on whether you're talking about SQL or relational algebra, I generally refer to this as the target clause. Um, the from clause essentially defines a list of tables or relations that you're analyzing. The relations may also be aliased or assigned a range variable. Um, then the target list essentially tells you what attributes you want to see in the result. Those are attributes that should show up in the relation list. And then the condition is essentially just a Boolean predicate that tells you which records you are interested in seeing. There's an optional distinct keyword that asks for you to remove duplicate records as well. Now, kind of the naive way of implementing SQL is to take all of the possible combinations of tuples in the relations. You take every one relation, one tuple from relation one tuple from relation two, one tuple from relation three, and so forth. And then you take the full combinatorial collection of pairs. Um, then you keep only the tuples that pass the condition, and you delete any attributes that don't show up in the target list, or you remove those elements of the tuples. And then you eliminate duplicate rows if distinct is specified. Now, as with most things in the class, the first thing I present to you is the correct algorithm. It's not necessarily the most efficient one. And what a database system will do, and what we'll cover in the bulk of this class, is essentially ways to start with this kind of default query representation that we know to be correct, and then go through a series of transformations that we can prove preserve the correctness of the result, while at the same time allowing us to be a lot more efficient in how we generate the answer. Give you a couple of really quick examples, and for these I'll be using the New York City street tree map. So the simplest query that you can pose in SQL is give me all of the records out of a table. And so here I'm going to select star from trees. The wildcards star or table name dot star are special targets that essentially just say, give me all of the attributes in either all of the tables or the specific table that I'm mentioning. So in this particular case, I'm going to produce a bunch of different columns, and well, there's quite a few of those. Okay, so another thing, so maybe I'm interested in a subset of that data. So I might pose a query like this, and let me enable the poll for that. So here's a query. What does this compute? You know what? Let's actually make this easier. On chat, what is the query computing? Yeah, I'll leave Slido up if anyone wants to answer there. It's gotten really quiet. Fairly certain that this is not Streamlag because I see YouTube broadcasting. Okay, great. So yes, Preetham, the query is essentially asking for the tree ID and the common name and the borough name of trees that are located in Brooklyn. Um, so, yep, there's an example answer. Here's another one. This is a little more tricky. Here's another query. What is this query asking? And I'll give you a few more moments. Okay, nice. Okay, nice. So yes, this is basically looking for trees that have yep, Preetha Musam. Um, this is looking for trees that have a bad smell, and uh, this is a little bit interesting because um, the unpleasant smell attribute lives in the species info table, but what we were looking for is the actual trees throughout. So what we have to do is kind of link those two tables up. So they both show up in the from clause, and then we essentially figure out we kind of link the two based on the common name and the name in the species info. Now, this is also an opportunity to talk about aliases or range variables. So using trees or species info, the full name is often a little bit cumbersome. So you can always take tables, relations, and alias them, either by putting trees as T or just trees T for short. That essentially just means throughout the query, we're going to use T dot and then the table name to refer uh, to that particular table. And you can often also omit uh, the alias or the table name as well, as long as the attribute is unique between all of the relations that you're querying. So you can refer to just latitude or just longitude because those only occur in trees and not species info. And this, by the way, is one of the examples of the many bits of syntactic sugar that the Spark analysis phase is used to eliminate. So Spark has a particular feature that allows us to easily keep track of unique attributes. And the analysis phase essentially kind of wires up all of the attributes together. Fantastic. Okay, expressions. You can, in addition to having attributes, just raw attributes in the target clause, you can also have expressions. And if you have as expression as name or name equals expression, that will assign a name to the result of that expression in the resulting table. Um, the uh, you can do pattern excuse me, you can do pattern matching on tables. Um, so SQL provides a approximate string matching framework called like, so string like and then pattern. And in general, this shows up mainly with the percent sign. There's a couple of other symbols. Question mark matches one character, percent sign matches 0 or more characters. Union allows you to combine the output of two different tables together. If you just have a bare union, that computes the set union, or in other words, the union excluding duplicates, and union all will preserve duplicates, so you'll end up with a bag union. And then aggregate queries are essentially a way of computing statistics over the resulting data set. So aggregate select queries, while they may look similar, are actually a bit different. And they're identified by a couple of extra clauses or by one or more aggregate functions in the target list. So the target list now has to contain only grouped attributes or aggregate expressions. In other words, expressions that compute an aggregate statistic like a sum, a count, or an average, or a min, or a max, or there's dozens of them. And the idea is essentially we're going to take all of the results, we're going to group them into groups based on the grouping attributes, and then we are going to compute an aggregate statistic for each group or multiple aggregate statistics. There's also an optional having clause that is going to translate that is also going to allow us to apply a filter on the resulting groups, and the having clause can also include aggregate statistics as well. Simple example here, the number of distinct trees of each common name would be expressed by species common count star. So count star is going to give us the count, and group by species common is basically saying that we would like to construct one group for each unique common name, and then the count aggregate is going to be computed for each within each group. Okay, so that is what I have for you today. I'm happy to hang around for a couple of minutes to take questions. But apart from that, Thursday we're going to introduce Scala for Java programmers. Um, if you already know Scala, you probably don't need to be there, but you're welcome to show up if there's any tips, tricks that you might be interested in. Apart from that, thanks, and show up on Piazza if you have any additional questions that I don't answer in the next 5 minutes or so. Are the lectures recorded? And so Elisha asks, are the lectures recorded? And Canvas will be asking for a course code. So two things. Let me answer the first question. The lectures, YouTube will preserve a record of the lecture. So if you go to the same link immediately after, or probably like half an hour after the recording ends, the lectures will be present there. Canvas asks for a course code, so apologies for the confusion. Canvas looked like a good resource until I started asking students to sign up for it, at which point it stopped being quite as friendly. So I've decided not to use Canvas. I'll be using Piazza instead. There's a link on the course website. Nathaniel asks for will the slides be available on Piazza? I So it's a little hard to upload the slides to Piazza because they're HTML, but I do link to the slides from my from the course website. So you can always ask them for the you can always access them from there. Um, Bendretti Sandeep asks join versus union. So I don't exactly know what the question is there, but I'm going to take a quick shot at it. Um, so joins are essentially accomplished by putting multiple relations in the from clause, and what that essentially means is we're going to take tuple. A join is essentially taking tuples from one table and matching them up against tuples from a different table, and essentially finding some subset of the matches. So, for example. So, for example, um, this query here is a join. I'm essentially taking records from the trees table and records from the species info table, and I'm trying to pair them up. In this particular query, I'm essentially saying that I'm specifically interested in pairs that have the same common name in the trees table as the species info, the corresponding species name field name attribute in the species table info table. So a join essentially takes tuples from two different tables and pairs them up with each other. A union, on the other hand, if you want to think of it, a union essentially pairs two tables together horizontally. A union essentially takes all of the records in one table and all of the records in a different table and just creates a new table that has both sets of records. So you can think of that as combining two tables vertically instead. Um, Pritham asks, if you can use Python instead of Scala. Unfortunately, no. I am open to letting people use Java instead of Scala. Um, Scala and Java are to some degree compatible. Um, However, Scala has a number of features that makes it much more effective for use in a compiler or an optimizer like the one that we will be building. So I really encourage you to use Scala. Um, Scala's build system does natively work with Java as well if you feel more comfortable using that. Um, in principle, other JVM-based languages are also open. I am open to requests for other JVM-based languages, um, but I would need a compelling reason to do so. Will assignments need to be handwritten and submitted in person? No. I'll have an online submission system. We'll be using AutoLab for homework submissions. Does the course have anything to do with data visualization? So largely, largely no. I will database systems form the infrastructure for data visualization tools. Like for example, Tableau just acquired a company called Hyper that essentially is their database system right now. Scala obviously internally has use of data, some tools for data visualization. Um, so while we won't be focusing on the data visualization aspect of it, there's also connections to different forms of data visualization, and I'll be actually. There's an interesting paper. I do have a class scheduled on approximate query processing. If there's interest, I can incorporate a fairly recent paper on how limitations of data visualizations, or like, you can never, you don't necessarily need a visualization more precise than a pixel. Like that's actually a trick that you can use to make query processing faster, make it faster to generate the visualization. Karen, by the way, if I butcher your name, please let me know in the chat. I'm horrible at names, so please let me know. Which algorithms are you expected to know? So I don't expect you to know any specific algorithms, but I do expect you to, um, I do expect you to have kind of the basic Google interview questions covered. Like, I expect you to be able to create a sort algorithm. I expect you to be able to uh, to look at an algorithm and tell me the worst case runtime of this algorithm is linear or exponential in the size of something. Are we going to study MapReduce? So interesting question. You are actually going to implement something better than MapReduce. In general, I do not. So MapReduce Spark is essentially what happened when database people looked at MapReduce and said, "Here's an interesting idea, but it's kind of crappy, and we can build something else in an afternoon." And then they did, and it was Spark. And so Spark you can think of actually as being a superset of the functionality provided by MapReduce. Filter or MapReduce essentially combines two operations in relational algebra and makes it very efficient. Okay, I shouldn't say very efficient. Makes it very easy to create a fault-tolerant distributed deployment of those two specific relational algebra operations. We call project and aggregate or group by aggregate. Um, Spark obviously has both of those as well. So we will not specifically refer to MapReduce, but we will definitely address the concepts that you would need to know. Mahek asks, will we have Scala tutorials? So yes, as see on the screen, or just a moment on the screen. Next class, Thursday's lecture will be Scala for Java programmers. This is going to be kind of a 1.5 hour whirlwind tour of Scala that you should be able to follow if you are familiar with Java or C++, C Sharp. Um, in terms of additional tutorials, the Scala webpage, let me bring that up. So if you go to the Scala webpage under Scala documentation, and I'll paste that link for you in just a moment. There is a ton of additional resources. If there's a ton of additional resources there, they're including tutorials, including Scala for programmers of different languages. Scala is an incredibly extensive language, and I can guarantee you there's precisely one feature, and we will talk about this feature on Thursday called match, that you need to know. Apart from that, it behaves pretty much, it can be used pretty much like any other imperative language. It's not, mastering Scala is hard. Learning enough Scala that you can use it and be dangerous, um, especially if you're familiar with other languages, is a lot easier. So you can there are plenty of tutorials out there, and again, I'm more than happy to work with you during office hours. Darshana is I don't want to speak for her too much, but like the working with getting people up and running on Scala is I expect going to consume a lot of our initial office hours. So please, there's a ton of resources available to you, and we will help you get up and running in Scala. All right, hopefully I've answered everyone's question at this point. We're a little bit over, so I'm going to sign off here, but I will be paying attention to Piazza. I will be paying attention to email, and if you have questions about anything in the class, I'm more than happy to answer them. Thanks, everyone, and see you on Thursday.